They will say, okay, I don't want my industrial equipment to connect to the internet. I want the data to be on my premise only, right? Then they can actually connect the this edge to the cloud, which is through internet, but all the devices are actually connecting to the edge, which is local in nature. So now there, this is a security concern use case. The other use case could be where you need to process the data onto the device itself for a faster analysis. Let's say a typical use case could be that every person entering into an movie theater, right, need to have a mask on his face to be able to go because it's a health requirement. Now, in this scenario, there will be a number of people walking into the queue, right? You can't actually wait for the video feed to go to the cloud, do the processing, and then send a message back to the device saying that, hey, this person has not wore the mask. You need to do everything on the edge itself. That's where you need to have an edge-based solution where you process everything on the edge, only use the cloud for important notification or storage or routing. That means just informing to the user that, hey, you have five people who has not wore the mask, so you take care of them. This is the fundamental difference between the cloud-based solution and the edge-based solution. I hope that it makes sense to everyone. Um, so before I sort of go into the deeper topic of what is the edge device, I can take a pause here and ask if there are any questions.
Questions?
I would like to ask that the whatever cloud services here, as you have mentioned, sir, like Azure, it could
Right.
be any cloud services, na, that can be
Yes.
connected with the edge.
Right.
And one more thing, sir, I would like to ask that is there any specific protocols for industrial IoT, like normal MQTT might not be helpful for the industrial IoT? Is it like that?
Yes. So there are specific protocols like OPC UA or ONVIF for industrial environments.
And sir, I think I have gone through the one literature where smart plug MQTT was there. It might be related with the industrial IoT, but I don't get it much more literature about it. So if anything based on that,
Uh, Smart MQTT.
smart plug MQTT, that is one advanced
Okay.
version of MQTT. It might have used for industrial IoT applications. Smart
Okay.
smart
Yeah.
plug.
Yeah. So typically there are two types of MQTT protocols. So let's say there could be an open source MQTT protocol. Now MQTT is an application level protocol like HTTP. However, there could be different libraries who are implementing the protocol. So what you're talking about is a smart plug MQTT, which could be related to adapters or the plugs that we are using, right? But in terms of the cloud always implements the native MQTT, which is a stack that can integrate into any device. So it's a pretty standard SDK that comes that runs on the edge runtime environment when we talk about the Azure-based cloud solution. So Microsoft Azure itself provides you the MQTT library, which you need to ensure that runs on the edge device so that it can communicate to the Azure cloud, which is called as an Microsoft Azure IoT Edge. Similar way, if you are implementing AWS, AWS provides an AWS Greengrass runtime environment, which has a
Yes.
MQTT library or an SDK that you can use to communicate back to the cloud.
Yeah. Thank you, sir.
Yeah, sure. Okay. Now we go to the edge device specifically. So now we are talking about a specific component, how you can actually do the device development. I'll not go much deep into this subject because it's a subject of an embedded device, but I'll briefly provide you an overview what an edge device means. So an edge device is nothing but a microprocessor which is less expensive and is simpler to operate. So an MCU typically contains functions, memory, interfaces, input output, which is nothing but a chip itself. Okay. MCUs, they often use an OS called an RTOS, which is real-time operating system that runs on a bare metal device. And it provides a real-time responses, unlike our desktop or laptop devices, which is using Windows or Linux as an operating system. And this is a highly reactive event-based operating system. So this is generally used for the purpose of building a device. So device requires an agility, a quick response that you can send it back to the cloud. For example, today there is a service called Azure Sphere, which is a secure high level application platform that is built for communication and security for internet device protocols coming from Microsoft. And it comprised of secure connected MCU, or it contains the capability for an Linux-based operating system which can communicate to the cloud. So you can actually use the open source RTOS, or you can use the Azure Sphere that simplifies the integration with the cloud and build your device. Now, what does the device do? Very simple. It establishes a connection securely with the cloud, sends the telemetry data, messages that contains the device state, synchronization with the cloud, and response to the command sent from the cloud. And it enables the installation over the air updates of the software and pushing the configuration back to the device. So basically, a device is nothing but an operating system that enables communication from the device to the cloud, cloud to the device. Now, keeping it very simple so that you understand that what kind of capability a device can have. And then you can use the Azure Sphere or RTOS or Azure SDK to communicate these particular messages to the cloud. I hope that's pretty clear, and you can relate it to the actual world where the people make the IoT enabled devices. Now, once you have the device in place, the first thing that you need to do is connect that device to the cloud, right? So this particular concept is called as a device connectivity, where we exchange data with the cloud services and device facing the cloud endpoints. So device is actually consuming the cloud facing endpoints, where it has to authenticate and establish the communication protocol through a gateway, and then communicate back to the cloud. So what are the major things that are considered in this particular device connectivity? So this is an infrastructure element. For example, a gateway. A gateway is nothing but again a software that runs a typical Linux-based operating system that communicates to the cloud. Now, what does it include? It includes the device to cloud communication or messages that typically sends the telemetry data. For an example, let's say I want to build a very simple use case that what is my room temperature if I keep my air conditioning on let's say setting the temperature as 24, but actually the room temperature could be different, right? It may not be 24. So I want the air conditioning to keep sending the temperature data back to the cloud every maybe a minute or maybe every half a second, half a minute. And then I will aggregate the data of 15 minutes and show it on the mobile app to the consumer that, hey, the current last average temperature of an hour is roughly, let's say, 26 or maybe 25 of the room itself. So I have a room temperature that is installed in the air conditioning that is measuring the temperature of the room. Then it is communicating to the cloud through the gateway. In this case, the air conditioner itself is gateway as well. And then it is using the connectivity to send the messages to the cloud. Cloud aggregates that message and show it to the user on the mobile app when they launches it. So this is called a device to cloud. Now imagine that a cloud to device communication is required for, let's say, configuring the air conditioning or maybe configuring the device saying that, hey, uh, this temperature is not good for me. I want to have a room temperature which is less than 25. So I want to change the air conditioning temperature to, let's say, 22. Then on the mobile app, you can actually change the temperature to 22 and let the cloud know that I want to change the configuration in the air conditioning to make it 22. So instead of using a normal remote control to change the AC, you can actually do it through the cloud. Now, this is a very simple example. Imagine a real world situation where, let's say, a typical application, a real application could be a smart audio video doorbell, which is installed on your door. The use case is that whenever somebody presses that doorbell, and if I'm not at home, it should show me a video feed and allow me to do an audio video communication. So this is now a complex scenario where the moment you press a button, the device communicates to the cloud and sends a video feed that you can actually see on the mobile application here in the cloud. And once you see the mobile application, you actually enable the audio to communicate back to the device so that a speaker on the device can communicate back to the person standing on your floor or standing in front of your gate. So this includes device to cloud communication and cloud to the device communication. So this is a typical device connectivity scenario where you are actually authenticating the device and then using the protocols such as MQTT or HTTP to communicate back and forth. Now, how do you authenticate the device? So device authentication is typically being done through the certificate called an X.509 certificate, which is unique to the device. So today it's very common, right, that we get a device from outside, let's say Alexa or something like that, right? And you scan the QR code and activate the device, right? Saying that this is my original device. I want to activate so that I can use its services. That is typically done through the certificate, which is running into the device called X.509, which is unique to the device. And that certificate is being communicated to the cloud through the device provisioning service, which in turn authenticates the device and allows the communication back to the cloud. So we talked about exchange, cloud endpoints, authentication, and communication protocol through the use cases. Now, once we have the device connectivity in place, we do the device management and control. Now, what is device management and control? Device management and control is a key concept that talks about the managing and controlling a typical IoT device. So what does it mean? It means registering the device, provisioning, deployment, updates, key management, monitoring, and enabling and disabling the device. So now, what does in registration means? A registration means I am using a unique device ID and authenticating the device through the certificate to register to the cloud that, hey, I am an authenticated device. Today we do that with Aadhaar card, right? Every time you go to a specific service, let's say you go to the income tax website portal, they say, do you this is your linked Aadhaar card to your income tax login. Do you want to do the OTP based authentication? We say yes, and then we get login. Now device can't do that. So registering a device through the unique ID and using a unique certificate will allow the cloud to trust the device. And the device registration is always stored in the software or the component called device registry. So imagine that you are rolling out 1,000 devices in the market with a unique ID and a unique certificate, and you only allow those 1,000 devices to go back to the cloud, and you cannot allow any other device to communicate to your service. That's how you authenticate a proper device. Now, once the device is registered, you provision the device. Now, what does it mean by provisioning? So it should actually, provisioning is an approach that basically register a device with the cloud services called IoT Hub. Now, what it means is that this device is registered, but now it is being provisioned to communicate to the Azure cloud. That means now it has the ability to communicate to the cloud services, right? And then you have the deployment of the device. So what it means is that it's a process of installing the software onto the gateway. So once you have the uh, device registration and device provisioning being established, you actually also provision the gateway with the IoT Edge runtime so that it can communicate back to the cloud. So device provisioning service is an general service that you can use to also provision your device for deployment. And then you can regularly do the update to the device through the firmware updates, and you can do the key rotation so that your device always has the fresh key. And then you can monitor and enable and disable the device through cloud. So this is called in device management and control. Now, Azure provides a IoT Hub as a service so that you can do the complete device management and control. And it also has a service called device provisioning service, which is a global service which you can use to provision n number of devices in the cloud. Sorry. Now, once the device is registered in the cloud, it actually needs a message routing mechanism so that it can actually send a message to the cloud and the cloud can process it for any service. So IoT hub routing is an capability of a message routing. So when I say message routing, I mentioned earlier that a devices could be a complex where it can send heterogeneous data to your cloud, and then your cloud actually enrich, process, and transform the messages so that your application can understand the uniformal mechanism of the data coming from the device. And that's called a message processing, wherein uh, IoT Hub provides a routing mechanism where you can actually have a queue, have a topics that can actually process and store the data so that it can go back to the cloud in the uniform manner. Once the data is processed in the cloud, we talked about what do I do with that data. So let's say uh, we take an example of let's say a sales campaign where you are sending a data, maybe instead of sales campaign, um, let's say we have an agriculture farm where we have installed a temperature sensor or a humidity sensor in the entire agriculture land to identify that what could be the average temperature and the humidity when we do the irrigation of the crops. So all the data coming from the device back to the cloud will go through the APIs. So now you gather all the data, store it, and then you provide an API that gives you an average temperature for last 1 hour. And then you can actually visualize that data into the cloud through a portal or through a dashboard and integrate the different services. So when you extend your IoT solution, you can do the different types of an integration. You can actually integrate with Azure Data Health Services. You can integrate with Azure Data Visualization Services. Nothing but a Power BI is a tool that allows you to do visualization. Or you can actually use the IoT Central template. So this IoT Central templates is an application vertical specific template that you can use to visualize a dashboard. And that dashboard can be useful for you to achieve your use case. So these are some of the mechanisms through which you can implement a use case in Azure cloud that makes sense to your overall solution, or that makes sense to your overall uh, goal of the business. Now, uh, before I go into the advanced topic of Azure Digital Twin, I would like to take a pause and see if you guys have any question, because before I move into the advanced topic, I think it is important to address any question that is relevant uh, and more meaningful for you to clarify. Okay. Um, no questions, then I can move to the next topic. Analyzing and visualizing your data. So when you say about analyzing and visualizing your data, it's an thought process where you can get an insight out of your data and visualize it through a Power BI dashboard and integrate with Grafana for monitoring. So Power BI is a tool from Microsoft that helps you to visualize the different reports. And these visualization services can be used to identify and display any business insight that is derived from your IoT data. So let's say I want to count how many people entered this stadium today, cricket match stadium, to watch the cricket match. Or for example, I want to use a machine learning model to, let's say, identify the telemetry data and predict that when maintenance should be carried out on the industrial asset. Let's say we are talking about an robotic arm that is deployed in the warehouse. Now that robotic arm is manufacturing a car, or it is painting a car. Now, how do I predict that when this robotic arm requires a maintenance? So you can actually use the Azure Digital Twin to replicate the exact state of the device into the cloud and keep on gathering the telemetry data so that you can run an algorithm to create an insight out of it. For example, let's say a robotic arm is using a power supply or a battery backup inside it, which is through an UPS. And that UPS over a period of time will deteriorate its capacity, right? So how do you know that UPS now requires a replacement? So that robot is continuously reporting the UPS state back to the cloud. And at some point in time, it will generate an alert that, okay, this UPS is not useful now, so it requires a replacement. So these are the kind of use cases that you can do with your IoT data. Now, specifically, Azure Digital Twin is a service that lets you build and manage the models that are live and up to date. And it is a representation of your real world. So what you can do is you can actually query analyze and generate a visualization out of it, and extract a meaningful insight. So, for example, let's say we can create an Azure digital twin that represents a building that includes multiple rooms. Let's say we take a cricket stadium, and this is a live example that we as an InfoChips implemented for one of the large customer for FIFA World Cup. Now, FIFA World Cup is a very highly rated event, and it has a multiple set of fire detectors, then intrusion detection cameras, fire detection sensor, water leakage sensor in the bathrooms, in the changing rooms, in the dressing room. And all of this data is coming back to the cloud. So now in the cloud, we can develop a unified interface that can show that what is the current state of a given area. And then we represent it into the uh, image of a stadium that, okay, in this particular area there could be a fire, so now it requires a emergency help, or this particular area has a too much crowd because the cameras are saying that the capacity of the section is 500 people, but we are actually having 550 people inside that area, so it requires a real monitoring, or it requires people to move to the right places. So these are the kind of use cases you can implement through visualization and digital twin that can represent the actual state of the physical item or physical thing, right? Similar way, the Power BI is a tool that can help you to analyze and visualize the data. So when I say analyze and visualize the data, it could show you a real-time data coming from the sensor. For example, what is the let's say average usage of my car battery? We recently implemented an example for a customer where the car battery is communicating back to the cloud about the state of the health of its batteries, so that I as an battery provider know in the electric vehicle that when this battery requires a replacement. So these are the kind of use case that can help you to visualize the, let's say, real health of the battery. Or you can actually, recently, I don't know if you guys have seen the announcement from Microsoft. They have implemented a use case in agriculture where they can actually visualize the current state of the land in the agriculture. So they are taking a sample every day from the land and using the machinery to feed the data back to the cloud. So this is nothing but a device. And then cloud is showing a visualization that what is the state of the land in a particular area. So these are the kind of advanced use cases that you can do in your real time application. Now we talked about multiple use cases. Now we come to an moni- come to an subject where we talk about how do you manage your IoT solution. So for example, how do you monitor your IoT solution, or how can you implement the automated deployment of the solution, or how can you manage your backend tools infrastructure that is being deployed in the Microsoft Azure. So Microsoft Azure provides the monitoring services for their platform like Azure IoT Hub, device provisioning, IoT Edge, IoT Central, and digital twins through the Azure portal. So I don't know how many of you guys have an access to the Azure portal, but you can register for free and you can get a backend portal through which you can manage the virtual machine infrastructure, storage, and lot many things. Then Microsoft Azure provides an ARM templates. These are the templates that allows you to do an automated deployment of the solution. So let's say today you build a solution and deploy it into the cloud in a particular region, let's say in India. Now tomorrow you want to expand it to Europe. So now you have the template through which you can replicate the same in the year of region as well. Microsoft provides Azure CLI, which is a command line interface, and PowerShell, which can help you to manage your IoT solution through the backend command line tools. These are very important because when you deploy your IoT solution in Azure, you should be able to also manage it through very light interface like command line. And then Azure DevOps is a tool set through which you can implement a CI/CD pipeline. So let's say today you deployed a version 1 of the solution. Tomorrow you want to make it version 1.2 or version 1.3. Then how can you do that? So you have an automated deployment through which you can deploy the solution, deploy the items into the uh, a network or your infrastructure through the automated pipelines. So I'm talking about too much of an technology here, but is maybe Jignesh sir, I'm just asking you this question. Is it relevant to your staff who is attending, or is it very new for them, or it's something that they have heard but never experienced? I just want to understand, like, what's the uh, do you provide cloud access to your staff to teach to your students, or do you provide them in cloud environment to experience? How is your setup?
Most of the people who are attending is no one the things. Few of them are having the access.
Okay,
We are providing the access to students to the
okay,
cloud, but
great.
few students only are using that properly.
Okay, okay, okay. So, sir, I would highly encourage that there are very fundamental courses that are available on Microsoft Azure or AWS, where they introduce you to cloud and infrastructure and global scalability. Before getting into the advanced topic of, let's say, IoT, that could be very useful for your students when they go into the market or when they get an access to the industry. Because at the end of the day, industry is actually using this technology stack to build a real-time applications. And and that's where if your students if your set of engineers are aware that what is cloud and what is global infrastructure and what are the different services, that could be very useful for them in terms of adopting to the need of the industry as well as getting the right exposure into the market as well.
Sure, sir. We'll look into the matter and ask our students to do the courses, especially from the MOOC.
Yeah. Okay. So now I will move on to the other topic called securing your solution. So when I say securing your solution, security involves three things, and which is the very most important part of the solution. One is called a device security, then a connection security, and then the cloud security. So when I talk about the device security, it relates to securing the IoT device while it is deployed in the field. Connectivity security talks about ensuring that all the data that we are transmitting between the device and the IoT cloud is confidential, it is tamper proof, and it is secure in nature. And when I talk about the cloud security, it talks about securing your cloud infrastructure, your data stored in the cloud. So, so in the real world, when you need to secure a device, there is a service available in the market called Microsoft Defender for IoT. Maybe you might be already using Microsoft Defender for your Windows, right? Where it is securing the laptop or the desktop. Microsoft Defender for IoT can actually automatically monitor your devices and generate a recommendation that can be useful for protecting your device, and it can periodically analyze and provides the security state of your Microsoft Azure resource to identify what are the potential vulnerabilities of your solution or your device. And then it can help you to slowly provide a recommendation how you can address that. So you can actually enhance the, in the industry, it is called a security posture, which you can enhance. So a very simple example that you should not have a port 22 open on your device. It should be actually blocked so that nobody can SSH into the device through the public IP or the device connectivity. Or what you should do is you should disable the HTTP, the file transfer protocols onto the device so that the device is not vulnerable to the outside threat. Similar way, the device security also requires a minimum hardware capability or hardware security as well, so that hardware is not vulnerable to the outside world. Now, when we go to the connection security, there could be a different mechanism. One I mentioned is the use of X.509 certificate, which can securely communicate to the cloud, and it's called in certificate-based authentication. So your device has a unique certificate when it is manufactured in the factory, and it's communicating to the cloud through the certificate, and cloud is pre-provisioned in the device registry with the certificate so that it can communicate and recognize the device coming from the authenticated source, which can be allowed to communicate. We can also use the transport layer security. So your devices can communicate through HTTPS, where if you are using HTTP as a communication protocol, then the device can use the secure layer to communicate securely through the cloud. Similar way, you can consider using the MQTTs or a secure MQTT as well, which comes with the certificate or the security toolchain that communicates back to the cloud and the device. Now, when it comes to cloud security, it talks about the how you follow the secure development lifecycle or the methodology. So the development requires you to go through the or rather, I would say secure development lifecycle, where your software should not have, let's say, SQL injection, cross-site scripting, no endpoints without authentication tokens. These are some of the mechanisms through which you can secure your application, and you can protect your credentials. So it's very important that none of your services are exposed to the outside world without credentials. And specifically when it is talking to the device, it should talk with the specific certificate or the credential only. And then you can define a role-based access control. So let's say an IoT application could have a different set of users. It could have a technician, it could have an administrator, it could have a business user, or it could have a global admin. Now, all of the people should have access to this infrastructure only through the role that is being played by them. So global administrator might have a full access, while technician might be only able to register and provision the device, while the business user might be able to only see the analysis or the dashboard or the visualization, while the global admin can have access to everything. So he can sort of help anybody in the organization. And then you basically monitor and define your solution through network-based security as well. So you can put in firewall or network security group that are available in the Azure that are uh, more useful for ensuring that your device is secure, as well as your cloud communication and stack is also secure. So that's what the security is all about. I have talked very briefly about security in this topic. It's a very large and complex topic where each of the layer can get into a security uh, uh, subjects and can really go deep into what implementations are required from a security perspective. Now, in the real world scenario, what is the purpose of the cloud? The purpose of the cloud is to have an application which is near to the user. So we talked about scalability, high availability, and disaster recovery. So today, if you are accessing any global application like, let's say, Microsoft Office 365 or Gmail, they are actually deployed near to where you are. So they are highly available solution and they are scalable to cater to a millions of millions of people. Similar way, when you design your IoT solution, uh, for example, we have one of the customer who has 30 million devices in the network, deployed across US, Europe, and African geography. So the solution is highly requires an high availability and disaster recovery. So in cloud, if you have heard, there are multiple regions, multiple availability zones, and multiple data centers in which you can actually deploy your solution. So this high availability and security requires, disaster recovery requires a scaling of your solution. So you can deploy your solution in multiple regions and you can use the Azure IoT Hub or device provisioning service, which are global service, so that they are not prone to a failure and they are globally available so that your solution never fails. And a disaster recovery refers to a concept where you deploy your solution at least in two places or maybe three places so that if in case your solution at one place fails due to natural calamities or maybe due to disaster or connectivity loss, you can fall back into the another place and keep your solution working. So that's about the high availability and disaster recovery. Now, when it comes to scalability, in Microsoft Azure, you can have a serverless architecture. That serverless architecture talks about provisioning of a function or provisioning of a resource that can execute the function or an event based on the data coming from the device. So let's say on every temperature telemetry data scan that is coming to the cloud, you want to process that data and store it into the, let's say, database. So you can write an Azure function that accepts the message, process it, and store it into the database. As simple as that. So that way, even if you roll out millions of devices in the market for your use case or your solution, you can scale it for an unlimited number of infrastructure, unlimited number of devices, and you don't have to worry about ensuring that your scale is meeting your business requirement. Cloud itself will take care of that scale if you use the right set of services. So when you design your IoT solution, you also have to keep in mind that it is scalable, highly available, and it is recoverable in case of a disaster situation. So these are the key aspects that cut across the solution apart from the business, where you have a security, solution management, and high availability and disaster recovery for a scalable IoT solution. So before we close the session, I would like to touch upon one case study which is on the cloud that really gives you an idea that how the real world operates. So before I go to this case study, I would like to, take a pause here and see if you guys have any questions on any of the slides that I talked about, and then I will go into the case study. That gives you an idea that how real world, uh, business is deploying such a solution at scale into the production.
Participants, do you have any questions? Okay, sir. Sir, you can go ahead.
Excuse me, sir,
Okay,
ma'am.
sure.
Yes, sir. One participant has a question. Miss Mona Lisa Ghosh, ma'am.
Yeah,
Yes,
sure,
ma'am.
ma'am,
You can
please.
ask.
Yeah.
Hello, hello.
Sir, can we unmute them?
Am I audible, ma'am?
Yes, you are
sir.
audible,
You
sir.
are audible. Yes, sir.
Yes, you are audible.
So my question
Yes.
is it is related with the energy optimization migration services, specifically in IoT solutions.
Mhm.
So is there any possibility that we can find out some solutions related with the energy optimization in case of migration services, specifically for the virtual machine migrations in this case specifically,
Virtual machine migration.
on the cloud basis?
Oh, sure. So in Microsoft Azure, they have a service called Azure Migrate and Azure Database Migration, where if you have a on-premises virtual machine or infrastructure or bare metal servers, you can use the migrate service to migrate them to a similar virtual machines in the Azure cloud, which is not related to IoT, but it is a general infrastructure service available.
Hello, sir. Am I audible?
Yes, you are audible, ma'am. Thank you.
Sir, I just wanted to ask, like, suppose if we are going for some kind of a live video streaming, so in such cases, if we want to utilize the cloud, so in what way is it possible? Like, because it is a licensed version, and also to the academicians, it is not easily available. By like we have a trial version, I think for 30 days. After that, it is a paid version. So so what are the possibilities of using it like for if we say the cases of like virtual reality?
So if I understand it correctly, your question is that how can I get an access to the cloud for academic purpose?
Yes, most probably like applications for such as video streaming, something of that kind.
Okay.
Like
So tip
it may involve processing also, so that can be done in the cloud. So yes, kind of that thing. Like okay, instead of just capturing the data, yes, some kind of a capture from the camera also can start with like 360-degree video.
Yeah, so you can actually utilize the different services such as in Microsoft, there is a video streaming service, which is typically very costly, but if I understand it correctly, for some sort of an academic purpose, if your college has an tie-up with a cloud service provider, they can offer you a student discount or maybe some sort of a student credits through which you can use the cloud infrastructure for use cases. And Microsoft does sponsor that in case if you are looking for and you are looking at a specific project implementation or you are looking at some sort of a you know implementation of a work that you want to execute for a government project or academic project. It's purely for research and development. To be honest, I don't know the process today, but I think it should be doable if you have the right connection, connect with service providers.
Okay, sir. Okay, thank you for the information.
Yeah.
दीदी इनको फिटिंग करना है फिटिंग तो बंद कर देना सब क्लोज पीलू पीलू चार्ज लेके जाओ मैं ले जा बोले अब पीलू
Yeah, please. There is a question from Viren Patel.
As we are all faculties here, and
Yes.
this is a faculty development program. So we have studied everything really nice about the real world implementations and what industry has adopted. But even considering an 5% of the capacity of what industry is using, can faculties or student groups can try to set up such a small cloud or IoT cloud on their own? Can such labs be developed? Is it possible? What have you to say about this?
Yeah, it should be doable. Uh, I think there are two ways to do it. If your organization has a tie-up with Microsoft, or maybe I don't know if you are using some Microsoft products for your internal purposes, then you can get benefits, uh, and then you can actually consume some of
Without
these
the
services.
Microsoft, without the Microsoft setting up our own open source kind of cloud, how doable would
Yes, you
that be?
can you can definitely do that. That is absolutely doable. But open source technology requires a different skill set where you need to go through the different open source platforms or solutions which are available in the market, evaluate them, and then you need a bare metal infrastructure on which you can deploy the various services for enablement of the overall IoT solution. But yes, it is doable. It is possible.
Any question, other?
Okay, then maybe I'll go to the case study slide, which is the last one from my side, and then we can um, keep 5 minutes for the question and answer. So this is a case study of a smart home and security platform where InfoChips has developed the complete platform and software as a solution capability for video streaming infrastructure for audio and video doorbell. So this customer has 27.5 million devices deployed in 7.2 million homes with 15 different product variants, and they have integrated with 10 different partner ecosystem. So this is a platform where today 256 plus million video is uploaded per day, and we are running 103 plus million AI-based smart notifications through the processing of 55 petabytes of video stored in the cloud itself. So the use case is very simple. You have an audio video doorbell that is available in the market, and that is something that you can use for your own, uh, you know, use cases such as intrusion detection, such as communicating with the person who is coming onto the door, looking at the live video, protecting your home through the security and surveillance, and being able to uh, yeah, run through the videos and making sure that you have the safer workplace and environment. The important aspect of this solution is that it is completely built on serverless infrastructure. That means this solution is optimized for use cases when you have a request coming from the device. Then only the cloud is used for consumption, and then only you have the ability to process the data in the cloud. So uh, this is the real world example where you can actually leverage the cloud for an unlimited scale, and this solution has been implemented into a production over a period of more than 5 years now, and this is into the production since uh, maybe 2018. And this is highly secure and scalable solution that you can implement in the cloud. This is implemented actually on AWS, and it has been integrated very well with the devices. So this is an end-to-end example how device can communicate to the cloud and can have the scalability. So that brings to an end of my session. Uh, I hope it is useful for the team who is attending, and it has an information that could be really helpful for you to guide your next generation talent to the right direction. So Jignesh sir, over to you. I'm available for another 10 minutes, open for any questions that team has. Um, and then we can close the overall
Yes, all participants.
session.
Yes, Kevur sir, you can ask. Hello, Kevur Nagecha sir. Hello, Kevur Nagecha sir, do you have a question?
Yeah, thank you. Sir, I have a question. Basically, I'm a civil engineer, and thank you very much for. I hope I'm audible.
Yes, you are audible.
Yes, sir, audible.
Okay. Yeah, thank you. Thank you very much, sir. So I am not the expert and I am not the faculty of electronics and communication. My question is a bit different because the last case, use case which you have stated that you deployed almost 27 point, I think 17 million home devices or smart home devices. Sir, I would like to ask the question that how far the reach is actually of the IoTs. Uh, if I talk about my personal experience, that since last 5 years, I'm having some uh, kit to enable the devices integrated with IoT, but I'm not using it. My question is that because I'm from building industry, construction industry, and you are based in Ahmedabad, how many architects actually are ready to integrate the IoTs in their design? Basically, what I understand is that you need the services if you want to go for the smart homes, because it cannot be an afterthought that once you construct and then you go for the smart homes or IoT enabled, you need basic
Yes, sure.
infrastructure. Yeah.
Yeah. So
So,
at
what
least,
is the actually, yeah. So my question is, what is the actual status of adapting the IoTs in construction industry?
sir, in construction industry, there are two different segments, right? One is an affordable segment and another is a luxurious segment, right?
Yeah.
Now, in construction industry, when you go towards in luxurious segment where people are spending for luxury,
Yeah.
then I definitely see an integrated audio video doorbells,
Yeah.
24/7 security surveillance in the construction industry. And at some point in time inside the home, people are demanding for smart lighting, then IoT enabled lighting, where I can switch on and switch off the lights through my mobile phone. And they are also demanding for a sensor based water refilling into the tanks. And these are the use cases that I have seen already being implemented in few constructed buildings. So you have security, which is running a 24/7 surveillance. You can have an audio video doorbell, which is installed for every home. You have a Ethernet connectivity inside the home for deploying Wi-Fi. And once you have Wi-Fi, I think you can deploy many IoT use cases, right?
Yes,
Uh,
sir.
then a lot of builders are providing automated. So you have a tank at the top, right, of the building, and it refills automatically when the sensor detects the water level to be below the certain level, right? That's also an IoT implementation. And some of the other use cases where you have automated doorbells. So you can connect it to a security gate. Security can give you the IP-based audio video call, and then you can say yes, you allow somebody to enter, or do not allow them to enter. That's what I have seen. But some of the luxurious segment apartments that are coming in, they have a much more capability. So some of them provides a temperature sensor, some of them provides a water leakage sensor within the home. Some of them are providing humidity sensor, because uh, some of them provides a fire detection sensors within the home. So these are some of the use cases which are applicable to building. And in India, it is still at an adoption stage, but in outside world, building monitoring is a requirement from the government, where you maintain the health of the building.
Uh, Sir, just to add to that, sir, I know uh, that we are having the concept known as BEAM. That is what is you have said, that BEAM is mandatory in many countries. That is building information modeling, where you
Right.
can continuously, that is after the usage actually, you can actually continue monitoring the building, the health aspect of it, particularly maintenance and usability, functionality. But in India, we are not adapting to the BEAM, so it is not mandatory, and architects particularly are not
Yes.
keen to use the beam. They are just into the first level of beam, that is 2D architecture mainly, or at the most 3D.
Right.
My another question is that because everything IoT is housed, whether it's a smart home or it is an industrial device or wherever, so you need the physical installation of the devices, and for that you need the persons who can actually understand and install that properly. Mainly, I believe that for IoT you need the Wi-Fi, or you can say the internet connection to work it properly. That is what I
Yeah.
believe. Uh,
Correct. You're right.
yeah, but
And
yeah.
absolutely. See, in India, to be very honest with you, uh, labor is more cheaper than connected devices, right? So
Yes.
a society would afford two full-time security, staff, compared to installing the devices into the multiple homes and monitoring it, right? So that's why you still don't see the adoption in India. But today, if you look at audio video doorbells, they are predominantly available in most of the houses, right? So wherever there is an applicability, I think people are making a use of it. But since in India, so-called labor is available easily and accessible, the IoT implementation is still not as advanced as what we have observed with some other countries. That's absolutely true as well.
Yeah. Thank you very much, sir.
Sure.
That's it for now. Thank you, sir.
Thank you. Yes, sir.
Thank you so much, sir, for your knowledgeful session.
I think there are a couple
Ma'am,
of
one
other
minute. There is a
members.
question from Nikhilesh.
Yeah.
Nikhilesh, sir. Yes, Nikhilesh, sir, you can ask.
Nikhil, sir, you can ask your question.
Am I audible?
Yes.
Yes.
Okay, thank you, sir. Sir, I want to ask one thing. Can you tell me in the brief what is the role of digital twins in IoT and how it works?
Digital twin is, in very simple word, a state representation of the physical world.
Yes.
So in a very plain term, if you have a device in the field, uh, which is very far and in the hazardous condition or very difficult to reach condition, you can replicate the state of that device into the cloud, and that is referred as a digital twin. For example, you can replicate the state of the stadium into the cloud, where stadium could have a fire detection, uh, a sensor, water leakage sensor, temperature sensor, humidity sensors, and all of that can report back to the cloud, and then you can represent it into a nice dashboard that shows you the state of your stadium at a given point in time. And that's a real use case that is being implemented by some of the people in the field, or some of the advanced infrastructure that has been built, like it has been deployed in FIFA World Cup when it has happened in Qatar uh, back in back in I think 2022 or something like that. So that's the digital twin.
Okay, it's very important right now. Is right now globally many kind of the areas they can use to the digital twins. So that's why I'm asking you, sir.
Yeah, sure. No, the adoption
Okay.
is very high. So there are industrial automation. For example, you take an oil and gas industry, right? Oil
Yeah.
rigs. They implement the digital twin because you can't send every people to every location of the oil rig because of the hazardous condition, right?
Mm,
So it is definitely an technology that can solve a problem for sure.
okay. Yes, sir. Thank you. Thank you very much.
Sure.
Any other questions from the participants? You can raise your hand. Puneet sir, yes, he has raised his hand. Yes, sir, you can ask.
Hello, am I audible?
Yes, sir, you are audible.
Sir, is there any AI-based solutions are used for, say, network security of IoT environment?
Yes. So when you say AI-based solution for network security, there are tools available who can actually scan the devices for the security gap, or scan the devices for the security vulnerabilities. And then it can basically show you the report, or it can basically give you the recommendation that what you should do to avoid that security risk. Uh, but there are no, I mean, there are no solution that will go ahead and fix the security issue. That there are tools which are available for recommendation and improvement, or maintaining the security posture of your device when I'm talking about the IoT, so that you ensure that your devices in the field are secure, and they are always communicating to the cloud in a secure manner, and they are not vulnerable to the attacks from the outside.
So, sir, is there any opportunity to implement IDA system for IoT environment?
Which environment?
For IoT environment, is there any opportunity or possibility to implement the IDA system?
When you say
Intrusion
IDA,
intrusion detection system for
yes,
IoT environment.
yeah, you
For
can
for
implement.
whole for whole say for example, you have given the use case like smart home for whole smart home system. So is there any possibility to implement the intrusion detection systems for that purpose?
Yeah, there is an implementation already in the market where you can actually implement the intrusion detection through the IoT enabled devices. So basically, you do the video analytics through the feed that is coming from the camera, and you define what is an intrusion for you, right? So somebody walking at your society gate between 5 to let's say morning, maybe in the night 1 a.m. to 6 a.m. It could be an intrusion, right? Because you're not expecting anyone to be walking at that point in time, right?
Sir,
So
sir, I want to ask in terms of say the network security part, because there might be possibility of different cyber threats or attacks on the IoT network. So how to say defend that or identify the different kinds of attack from, you can say, network traffic or something.
Yep. So let's say there are tools available which is called an SIEM tool. So that is Microsoft has a tool called Sentinel, which is an SIEM tool. Where the SIEM stands for Security Information and Event Management. So there are tools available who can help you to maintain the SIEM posture of your IoT devices. So these tools are already available in the market through which you can implement the security. So it is possible that you can integrate those tools into your solution, and you can actually do the threat detection, or you can improve the security operations. You can do the regulatory compliance, and there are a lot of other use cases that you can do with this SIEM solution. So there are specialized tools. So Microsoft Sentinel is a tool that you can use for such kind of a security implementation. It's a dedicated tool for security itself.
And sir, last question, where we can implement or where we can use this tool in the IoT system? Means on you can say network side or cloud, on the cloud environment.
You can use it for device, you can use it for cloud, and you can use it for the security is over and above the anything. So you can implement it for device, you can implement it for cloud as well.
Okay, so thank you.
Yeah.
Any other questions? Dr. Varsha Bhosle has raised her hand.
I want to ask one question. What are different types of career opportunities for the engineers which are working on the projects based on IoT, ML, and AI?
Okay, so okay, from the career perspective, if I look at InfoChips, there are 4 segments in where we operate. One is an embedded systems and embedded software, where you can implement the device and the real-time operating system on the device itself, which is called an embedded firmware and embedded software. So one career opportunity could be that engineers can become an embedded engineer, and they have the ability to work with the device and implement the real-time operating system and make it functional. The other could be that engineer can go towards the digital engineering, where they can look at the capability to integrate the device with the cloud, uh, write the um, write the remote device management application or vertical specific application, or they can actually do the mobile application development. They can do the complete application development life cycle, basically. That's a one opportunity. Within the digital, they can go for the data analytics or machine learning or AI engineer capability, where as a career you can become a data engineer to process and store the data in the cloud, or you can become a data scientist to understand the data and brings an insight out of it, or you can become an AI engineer where you can integrate some of the AI services into your solution to build a AI model based on the data that is stored in the cloud. So these are the kind of a different career opportunities that an engineer has. And if somebody is looking for purely an QA testing and validation kind of an area, then they can actually look for And carrier where they can do the automated testing, and they can do the manual testing, they can do the use case verification, and ensure that the use cases or the end-to-end solution works the way it is expected before it goes into the production. So these are the broadly 2 or 3 categories in which you can build your career as an engineer.
Okay, sir. Thank you.
Yeah.
Thank you so much, sir, for your insightful session today.
Sure, ma'am. Thank you.
Now, I request all the participants to once again turn on their cameras for one more photo session with our second expert of the day 3 of ATAL FDP, organized by Department of Electronics and Communication.
Madam, I am not able to on my camera.
Can you please provide the rights, the team?
Actually, that right is with their device only. Maybe they have not permitted the MS team to webcam. We have not taken that right.
Okay.
Yes, ma'am, it's done.
Okay. Now you can turn off your cameras. Thank you for your active participation.
Thank you.
Thank you, everyone.
Thank you,
Thank you,
sir.
sir,
Thank you
once
very
again.
much.
Bye-bye. Thank you.
Thank you. Thank you, sir.
Thank you. Thank you all. Thank you.
Thank you.
Sir, any other instructions to be given?
No, just
Okay.
if means we have created a class. So today I think there is only some 1 or 2 issues were found, and that is just because of I think their junk folder and all. But still, if any participant is having any difficulty, they can contact me, Jignesh Joshi, or Dr. Dipesh Kamdar. We are the coordinators for this ATAL FDP. So we will sort out the issues. Thank you very much. Still, we are here for next 2 minutes, and then we'll end the meet. So team, you can end the meet after 2 minutes.
Hello, sir.
Okay, sure.
Hello.
Yes, ma'am. Yes, ma'am.
Sir, actually, firstly, I have attended the meeting, but I could not fill that form, the feedback form. So,
Okay, you just
because I
write, no problem. You just write down your name, email ID on my email ID, right?
what's your email
I
ID?
will share. You send your email ID and phone number, mobile number on my email ID, my email ID, or you just reply on FDP coordinator.
Okay.
Okay.
Okay, sir.
Yeah. Okay. Okay.
Yeah, thank you.
Yeah.
So you can mute myself. I'm driving. Thank you.
Okay.